Welcome everyone. This time again back with the HC Verma problem solutions. And in today's lecture we will do all the river and boat type of problems. The river is flowing with certain velocity and a man is trying to cross or swim, or a boat is flowing against the wind river's velocity. We will need to find out the times, the distance, the angle, drift, and all these things. So question number 46 onwards in the HC Verma chapter 3 problem is all about the boat type of problem. We will start with question number 46, and I hope you have already tried this problem, that at least you understand what the problem is. So in question number 46 we have a river of 400 meter wide. Let's make this river is 400 meter wide like this. This distance is 400 meter, and we are given the river is flowing at a speed of 2 meter per second. From here, this river is flowing at a speed of 2 meter per second, and the boat is sailing with a velocity of 10 meter per second with respect to the water. So we are given this as 10 meter per second, and they say that this velocity is with respect to the river. And what does that term mean, with respect to river? It means that if let's say the river were still, completely silent, this man would have been sailing like this at the speed of 10 meter per second perpendicular to it. But what if the river is moving with 2 meter per second? This speed, as observed by someone flowing with the speed of the river, observe that he is moving with the speed of 10 meter per second. It's like that. You are in a train, and the train is, let's say, moving with some speed, and you start walking into the train compartment. Train is moving like this, and you start moving in the train compartment, let's say, perpendicular to this. Another person observes that you are moving in that particular direction, but someone outside the train will think that this person is moving in slightly like diagonal direction. So that is the meaning of a boat or a man swimming with respect to the river speed. That is the term I did not know when I was doing these problems in my class 12, because there was nobody who told me these things so clearly, what are the meanings of these terms, and that I had a difficulty even though I understood the other concepts of these things. So this is something very important. Anytime you say that he is moving with this speed with respect to the river water, it is the speed with which he will be moving, assuming that in the perpendicular direction, assuming that the river were stationary. We need to find out, number A, the time taken by the boat to reach the opposite. So let's say we need to find out this time t taken by this man to reach the opposite corner, and in part B we need to find out how far from the point directly opposite to the starting point does the boat reach the opposite mark. So when the man tries to go in this direction, the speed, the velocity of this river flowing in this direction will try to make it drift a little bit like this. So instead of reaching here, he is going to reach somewhere here, and we need to find out this distance x, or the drift, sometimes we call it a drift, along this direction. So let us do the first part, the time taken to reach this direction. And all types of this boat problem, we need to resolve these velocities in two directions. One in this direction, other in this direction, and then your life will be much easier. In this particular problem, the river velocity 2 meter per second is taking the boat in this direction. This river velocity has no effect whatsoever in making the boat move in this perpendicular direction. In the same way, the boat is trying to move in this direction 10 meter per second, and this velocity has no effect in drifting the boat along this direction. Separate this x-axis and the y-axis and you will be able to solve the problem very easily. So in the part 1, when we are trying to do the things only in the y direction, because we are need to find out the time taken in the y direction. So let's say we call it Vy is the velocity of this boat in the y direction. What is the resultant velocity? We don't know. But in the y-axis, it's going to be 10 meter per second. If this river were, for example, flowing somewhere in this direction, then a component of this river's flow would have added to its velocity in y-axis direction. But river is not flowing in this angled direction. Rivers usually flow in this direction. But I could make the problem more complicated by making the river flow at an angle of something like 30 degrees in this direction. But that is not the case here. So Vy here is just 10 meter per second, nothing else. That's it. And in this direction, we need to cover a distance. Let us call it as a distance y equal to 400 meter. And the time taken from here to here, everything in the y direction will be given by this time is equal to distance upon velocity. Both is measured in this y-axis direction. And that will be the y-axis distance is 400 meter and y-axis velocity is 10 meter per second. So this many seconds or 40 seconds. If this looks a little confusing, try to attend my lecture in riverboat problem in kinematics, where I have started with even simpler problem in even simpler concept, but I hope you should be able to follow this. In part B, we need to find out how much is this drift x. And again, now we are talking about the x-axis direction, so all we talk about is any velocity in this direction, drift in this direction, and time in this direction. Time will be same whether you drift in the y-axis or in the x-axis. So in the x-axis, let us say what is the velocity. The velocity, one is 2 meter, let us call it Vx, is 2 meter per second. The boat is trying to move only in the perpendicular direction and it has no component whatsoever in the x direction. But if I try to move in a little angle direction, I am trying to move deliberately in a certain angle direction, then I will have a component in the x-axis direction as well. But this is not the case here. So the x-axis, the resultant velocity is only the river velocity, 2 meter per second, and the resultant distance, let's say we are calling it x. That is one thing we need to find out, and we need to find, and the time in this duration will be the same the time as this, or 40 seconds. So from this we get in the horizontal direction, we get the distance x is equal to the horizontal velocity multiplied by the horizontal time, which is 2 meter per second multiplied by 40 seconds. And this becomes equal to 80 meter. This is question number 46. If you still have any confusion in resolving of x and y direction, just attend my kinematics lecture on boat problem and you should be able to solve these questions. Let's move on to the next question, which is question number 47. Let's read on. A swimmer wishes to cross a 500 meter wide river, again a river, and again its width is given as 500 meter. And then they say the river is flowing at 500 kilometer per hour. One thing you need to be careful, this is 5 kilometer per hour. These two units are different, so let's make this one 0.5 kilometer. Makes the things easier from the units point of view. So this is 0.5 kilometer. Okay. His speed with respect to water is 3 kilometer per hour. His speed is given as Again with respect to water. What does that mean? That this is the speed, you can think of that, in a still water, he would swim at, his speed with respect to water is 3 kilometer per hour. This is his speed. I am putting it here, 3 kilometer per hour. This direction shows that this is what the speed he would be swimming in a still water. If he heads in a direction making an angle theta with the flow, he makes an angle theta from here. He deliberately starts making, he does not try to swim here, he is making an angle here. What does that mean? That this attempt will have two components, one in this direction and one in this vertical direction, and that's what we will try to do to solve this problem. Find the time he takes to cross the river. Okay, so this is 3 kilometer per hour. Now this, if he tries to make an angle theta, then only a part of this, his velocity, which is this component, will help him cross this 0.5 kilometer. The other component, this component and this reverse velocity component, these two components will add, and both of these components will help him move in the x-axis direction. They will, both of them, this component and the horizontal component of this velocity, will drift them away and away from this opposite corner. And because this is moving at an angle, only a part of this velocity is available to cross in this river. So let us see, do Vy, the component of this velocity which is available to glide him in this vertical direction, that will be 3 sine theta. And what we need to find out? We need to find the time he takes to cross the river. Now this time will be equal to distance divided by velocity. And the distance is 0.5 kilometer. And the velocity is 3 sine theta. We can simplify it by writing 0.5 as 1 of this much of this many hour. We can write it as 1 upon 6 sine theta kilometer hour. Which is our, you can also, if you want, you can simplify it by writing multiplied by 60. 60 divided by 6 is 10 by sine theta per minute. But I think this is good for now. The next question is, find the shortest possible time to cross the river. Shortest possible time, that is T minimum. What is the T minimum? The T will be minimum when this sine theta, this is minimum when this whole thing is maximum. T is minimum when 6 sine theta is max. And when will this, what is the max value of sine theta? Max value of sine theta is 1, or when theta is equal to 90 degree. And at that of time, the time will be minimum, and this T min will be given by 1 upon 6 hour, or 60 divided by 6, or 10 minute. What it means that anytime you want to cross the river, all you have to do is you just try to go perpendicular. Your angle has to be 90 degree. If you are not in this direction, you are either bending either here, you are bending here, you are not giving your full in crossing the river. A part of your effort gets to either go along the river or going against the river. But it's not helping you in cross the river in the quickest possible time. So this is question number 47. Let's move on to question number now 48. Again, if it's not clear, things are not getting clear, spend some time thinking yourself. Riverboat problems are really very easy if you understand the concept, if you understand the separation of the horizontal and this vertical components. Consider the situation of the previous problem. So question number 48 is also related to question number 47. So let's move on to question number 48. Now in this one, the man has to reach the other shore at the point directly opposite to his starting point. If he reaches the other shore somewhere else, here or here, then he has to walk down to that point, because he has to somehow come back to this point. Find the minimum distance he has to walk. What does it mean? That we have to find out the minimum drift. Okay, so if this is the river is at 5 km/h, he is, let us say for the sake of it, that he starts at an angle of theta like this, and what will happen is that his drift is going to be more, because the river is also making him flow in this direction. A horizontal component of his velocity is also making him in this direction. In total, he will be getting drifted more and more along the x-axis direction, and that is not minimization. What he should possibly do is, instead of moving in this direction, he wants to minimize his drift, he should walk somewhere along this direction, and let us say this angle is theta. So the river will try to drift him along this direction, but a component of his velocity, horizontal component of his velocity, will try to minimize his drift. But you could also solve it by taking this direction also, and you will get an answer that this angle comes such that it is more than 90 degrees or something like that. So let us do with this one, because it is more intuitive. It is something like we can feel. So let us, in this condition, his velocity was 3 km/h. So the component of his velocity along this direction will be 3 sine theta, and this one will be 3 cos theta. Now the time to cross this river will be given by this time t is equal to distance divided by this velocity, this vertical distance divided by this vertical velocity. So this is 0.5 divided by 3 sine theta, same as we did in the earlier, or 1/6 sine theta. Now on the horizontal side, what is happening is this distance is 5 km/h, this velocity is 5 km/h, and this velocity is 3 km/h. So the net velocity is going to be 5 minus 3 cos theta. This is the velocity with, even if he is trying to move in this direction, you will see that it eventually moves up here. And the reason for that is this. See this 5. This net velocity is still along this direction, or as a net, because this is very small like this, and this is very big like 5 per hour, and this is, I'm trying to make it proportional. So you will see that the net velocity of these two things is still in this direction. The horizontal velocity will still make it drift, but we need to minimize that distance. So this is, we call it as Vx, the net velocity along the positive x direction will be this. And then the drift x, if we call this, because of this, let's say keep on moving, and then let's call this just drift and x, and this x will be given by this horizontal component of the velocity, 5 minus 3 cos theta, multiplied by the time it takes to reach from here and here. And in the time that it reaches from here to here, it will be the same as the time it takes to cross the river. The vertical component of the velocity makes it cross this river in y-axis. So this we can substitute for t here. It is 5 minus 3 cos theta multiplied by 1/6 sine theta. Now we can write it very clearly. X is equal to 5 minus 3 cos theta divided by 6 sine theta. We need to minimize x, And for this the condition will be dx upon dt is d theta is equal to 0. This implies, let's remove this constant 6 because it does not do anything for the condition. And to differentiate it, we have sine square theta on the here, and on the top side we have this term sine theta multiplied by differential coefficient of this minus 3 cos theta. Its differentiation will be 3 sine theta minus 5 minus 3 cos theta, and differential coefficient of sine theta is cos theta. This is the equation. This condition must be satisfied for this x term, this drift, to be minimum or maximum. We can write it as 3 sine square theta I want to make sure I am doing it right. Sine theta multiplied by the differential coefficient of this term, which will be 3 minus 3 cos theta. Differential is minus 3 sine theta minus this top term 5 minus 3 cos theta multiplied by differential coefficient of sine theta is cos theta. 3 sine square theta, 3 sine square theta plus 3 cos square theta minus 5 cos theta divide, it should be 0. Let's get rid of this sine square theta term. 3 sine square theta plus cos theta square theta is 3 into sine square theta plus cos theta square theta is 1 minus 5 cos theta is equal to 0. This implies cos theta is equal to 3 by 5. This is the condition that this drift is going to be minimum. And now theta comes positive, it means that our thought process was right. You could also start with this theta and you could have gotten a cos theta as negative value, which would have implied that we need to move in this direction. We can substitute the cos theta in here, but we also need sine theta. So sine theta will be equal to square root of 1 minus cos square theta, which is 9 upon 25. 25 minus 9 is 16. 16 is square root of 4 by 5. So we have sine theta, we have cos theta. Let us substitute it here and get that minimum drift. Minimum drift x. Let's make some space. These things I can go away. So x will be equal to 5 minus 3 cos theta is 3 by 5. 3 by 5 into 3 is 9 by 5 divided by 6 into sine theta is 4 by 5. 5 cancel. 25 minus 9. 25 minus 9 is 16 divided by 6 into 4. So this is 4 and this is 2 by 3 kilometer. This is the minimum distance he must walk, and in order to minimize his drift along the x-axis. That takes care of the 48. If you want, you can take a break and try the question number 49. Question number 49 is also falls into the same category of problems that the man swim problems, but we are using an aeroplane. So I will explain this problem first, and then you can probably try it on your own. An aeroplane has to go from a point A to another point B 50 kilometer away due 30 degree east of north. So whenever we are given east, west, north, south, the convention is we write east here, west here, this north here, and south here. This is general convention, but you can also choose your own convention. And need to go from point A to another point B 30 degree east of north. 30 degree from the north you get 30 degree east. So this is point A, this is point B, this is 30 degree. The aeroplane has to go from here to here, and this distance is given as 500 kilometer. A wind is blowing due north at a speed of 20 meter per second. This is the wind direction. I am making it like this, and the wind velocity is 20 meter per second. The air speed of the plane is 150 meter per second. Find the direction in which the plane should head. The pilot should head the plane to reach the point B. If the pilot starts heading in this direction itself, 30 degree east of north, what will happen is the wind velocity is here. The wind velocity will move it a little on this side. So instead of reaching here, he will reach somewhere here. So this pilot must head in a direction something like this. This is the pilot's direction. And let us say this angle is theta. Okay. Now what is happening? A component of this 20 meter per second this wind will act in this direction. The first thing we need to find the direction in which he should head the plane, and the B is the time taken by the plane to go from A to B. That will be the part 2. So I will say that you should try to see how the components of this wind is affecting this plane. The sum of this velocity, let's make it a very small, something like there, so that the sum of these two velocities should head in this direction. Now a component of this wind velocity is trying to the wind has, let's make the two components of this wind velocity. One component is helping the plane move in the direction that it desires, and another component is working perpendicular to that. So if there is any component of this wind which is working perpendicular to this direction, then that will drift the plane from here. And this plane is moving in this direction. It has a component in this direction. So I am resolving the plane's velocity in two directions. One, along the direction of our desired movement, which is very good, which is the direction we want to make it move. And helping moving in this direction is a component of this wind in this the direction AB. These two components are helping us move in our desired direction, and that desired direction is 30 degree east of this north. But there is a component which is trying to derail it, and these two components are the component of this plane's velocity perpendicular to this, and the component of this wind's velocity in this direction. And then three things can happen. One thing is that if this component is more than this component of the wind in this direction, in that case the plane will be drifting away from a little on the right of its desired direction. The second condition is, if this velocity, that is the wind's this component, is greater than plane's this component, the plane will be drifting, not go in this direction, but it will drift a little on this direction. But there is one condition: when these two velocities balance each other, in that case the perpendicular components will cancel each other. The plane does not drift in this direction, the plane does not drift this direction, it keeps going in our desired 30 degree direction. And for that, the condition is, if I call this angle theta, then the component of this plane in the direction perpendicular to this will be let us say plane velocity, which is given as 150 meter per second. 150 meter per second. So this component is 150. This is sine theta. So our desired condition for the plane to move in this direction is 150 sine theta, balancing the component of the wind in this direction when wind is blowing at 20 meter per second. So the component of this wind along this direction is 20 cos theta, and this 20, and along this direction is 20 sine theta or sine 30 degree. And from here we get sine theta is equal to 0, 0 cancels, 2, and sine 30 is 1 by 2, and this is divided by 1 by 15. Sine theta is equal to 1 by 15, or if we are asked sine theta, that will be sine inverse 1 by 15. And that is our part 1 of the question, and that is the most important one. Find the time taken by the plane to go from A to B. So there are two velocity components. This should be easy. I hope you can stop this video here and check it on yourself. There are two velocity components that are propelling. We already know that sine theta is equal to 1 by 15. There are two velocity components that are making the plane go in the direction of A to B. One is plane's velocity component in this direction, and other is the wind's component in this direction. So the net velocity will be this velocity 150 into cos theta, and plus the wind's component of velocity along this direction, that will be 20 into cos 30 degree. This is our desired velocity. This we can calculate. 150 into cos 30 degree is square root of 1 minus sine square theta 1 upon 225 plus 20 cos 30 is root 3 by 2. This term is, I am not going to calculate it exact. You can try calculating it. I will just try to make it exact. This term is square root of 224 by 225. It's going to be very close to 1. So I will keep it 150 plus, this is 10 root 3 1.7321 to 17.321. This will be roughly equal to 167.3 in meter per second. With this velocity, he has to move a distance of 500 kilometer. So the time taken will be equal to this distance, which is 500 kilometer, means 500 multiplied by 1000 meter divided by 167.3 meter per second. This is our time in seconds. We may be required to find this time to simplify in minutes. So I can do 500 into 1000 divided by 167.3 multiplied by 60, this many minutes. A little bit more of a 0, 0 cancels. That is, this is 5, 1, 2, 3, 4 zeros. 6 into 3, 18. 1, 9, 4, 0, 4, 1009.8. Should be very close. I can simplify it and I can write 3 zeros here and cancel these 3 zeros, and I get 50 minutes. So the key to this problem was if we want something to move in a desired direction, we want to make sure that it does not have any resultant component in the perpendicular. Net velocity component in the direction perpendicular to the desired motion has to be 0. This is the same for the boat problem, and this is the same for the aeroplane problem or any other problem. Just keep in mind that the direction will be determined that by the velocity component in that direction, and in order that it is moving in that direction, there has the perpendicular components, if there are any, they has to cancel each other, and that is the condition. I hope you understood it. If you have any confusion, I have a kinematics lecture on both problems, and you can visit that thing, understand the basic concepts, and do a lot of problems. I did some problems here, but what you have to do is do a lot more problem. And anytime you stuck into the problem, try to move to do the more simpler problem that will clarify your concept, then move on to the tougher and tougher problems. Also make sure you solve all the previous year question papers. If you are working on a NEET or IIT problems or class 11 problems, do as many problems as possible. What happens is, if you do a problem, if you stuck into it and you apply time, you increase your association with those problems. You clarify your concept even if you are not able to solve this thing. Thank you.